make it easier for you down the road to find just the bits of video you're interested in, so you don't have to watch my entire lecture again. So let's talk about assertions. What's an assertion? I talked to you about last time. What's an assertion? Exactly. Yeah, it's a demonstration that your assumptions, it's an operational check while the program is running that your assumptions are holding, that your assumptions are valid. This could be something as prosaic as, oh, I'm going to do an assertion that this certain variable is non-null. I'm going to do an assertion that I'm not being asked to divide by 0. I'm going to put into place an assertion that the string that's being passed to me to insert in the hash table is non-empty. Those are all things I could check. Maybe that's part of my specification. I only handle non-empty strings here. And if I'm getting an empty string, it's a sign that somebody's made a mistake in using my component. And this is the thing that catches them. On the other hand, it could be something much more sophisticated, ladies and gentlemen. It could be something like, I'm actually testing with this assertion that this whole algorithm returns something, this whole clever algorithm, a greedy algorithm or some very efficient algorithm, that it returns something that's the same as a brute force algorithm. It's a check that my merge sort or my quick sort returns something, a sorted list that's the same as the sorted list returned by bubble sort, which is trivial to write but really slow. So an assertion could be testing something more higher level like that this algorithm is working properly by comparing it to another whole algorithm, or it could be comparing something about the value of variables. This variable is greater than or equal to 0. Why would I do that? Why would I? And by the way, what happens if an assertion fails? So I'm checking this operationally, and it's great. If it's good, thumbs up, go forward, no problem. What happens if it fails? What do I do? Assertion failure? It stops the program. And it puts out a message that basically says, bad things happened here at this certain place. This is what went wrong. I was checking this assumption failed. And it failed at this place, this line number, in this method, in this class, that sort of thing. Okay? Okay, and why would I do that? Why would I want the program to just fail like that? To stop? Why would I want to have the program crash? Speak, you.
Because if the assertions are your basic sanity checks, then if the event they go wrong, the entire program is running on invalid premises, so nothing will be right.
Okay. So I like where this is going. Your name, young man?
Jonas.
Yeah, Jonas. So Jonas is exactly right. Now, what's the matter of it running on bad premises? Oh, just let it continue on. It's very wet, running on failed premises. Yes.
That if you're going on the assumption that it works by yourself, that you know that it works by yourself, the rest of your team will think that it's working as intended, while only one person in your team
Okay.
feels that it's correct.
Okay.
That it's not correct.
Okay. What's the matter with the program that's not correct running? Why not just let it run?
On the system, give full information on status replicate.
Yeah, folks, it can be disastrous if a program. We think often of a program crashing as being the worst that can happen. That's nonsense. Program crashing is not the worst that can happen. What's worse than a program crashing is a program not crashing when it's giving garbage out as results and you don't know it. A CEO of a company may be making a decision as to whether or not to let go of staff based on the outcome from this program. They may be deciding whether or not to merge with another company. They may be deciding whether or not a train should continue on down its track. And if it's working based on incorrect assumptions, that decision could be wrong. It could be based on nonsense, on data that was corrupted because some variable pointed at the wrong address. There's a loose pointer in C, and got the wrong data, got some uninitialized data from a variable, or what have you. This data can be based on nonsense, something that's meaningless, and you're hiding that thing. Ladies and gentlemen, if your program has mistakes, if it has problems, you want to know about them as soon as possible. Learning from mistakes. I told you, the one thing I want you to learn from this class, if there's one thing, it's that. So if your program has mistakes, you want to know about it as soon as possible, because it can be disastrous if you don't. Do you want to be doing your taxes based on numbers that are meaningless just because of the convenience of not having a die in front of you? No, if it's confused about what's going on and it couldn't understand a number, you don't want it to just hide that and just continue on and give you gobbledygook and have the CRA contact you 6 months down the line and say, you owe $5,000 more this year. You don't want that. You want it to tell you. So assertions operationally verify this, ladies and gentlemen. So you want it to fail early, fail hard. This is offensive programming. It's not really defensive programming. It's going out and finding bugs where they are, not waiting for them to come bite you. So these assertions actually quit the program. And there's other aspects of offensive programming that go along with this. Fill memory that's been initially allocated with illegal values until it's filled up with something meaningful, for example. So you can detect, am I accessing something illegal? If you have an enum, you make its default value be illegal so that you detect it as soon as possible. Just before an object is deleted in something like C, you might fill it with illegal data. So if there's still a pointer to it somewhere and you try to read from that, you'll get something that so obviously is bad that it will fail because there's an assertion based on it. Set buffers at the end of the heap, etc. Okay, enums, that's actually, we'll talk about this later in the term. These basically serve as a runtime sanity check in this class. We're going to be talking about the distinction from exceptions to return codes, but fundamentally, assertions find logic mistakes, development mistakes, things that should never occur. Ladies and gentlemen, they are not to handle things which are merely inconveniences. Give me some examples of things that are inconveniences. It might be handled by something like an exception, but not an assertion. What are some things that, it's up to us as software engineers. We don't like to deal with them. They're awkward. They're unpleasant to deal with. They're not the typical case, but we got to deal with them because they can happen legitimately in real-world situations. Give me a few.
Someone enters garbage into a text field?
Yeah, exactly. It doesn't cut it to say this user should be smarter. Oh, come on. Bullcrap. Maybe because you gave poor instructions in the first place, it's not a clear field. Or maybe they're, just from another country where you have exclamation points in names or something like that. And your program isn't smart enough to know. It's not them, it's often your system. So that's a good example, an excellent example. What's another thing that may go wrong? Actually, it's nothing to do with the user, but it's something we have to deal with. Yeah, I/O problems. So give me an example. Yeah, exactly. Okay, so you're relying on a disk that's been taken out, hot swapped out, for example, or maybe it's full, or maybe a file that you had opened before is no longer there. You ever move files around in your computer? That's legitimate, right? Maybe the file's gone. Maybe something got corrupted on this. These are things we have to deal with, folks. You can't just say, "Ooh, this will never be full." You're not going to go very far if you say that. You can't just say memory will never be exhausted. It just reaches a point where memory will be exhausted. And often the user is running on machines that are less honking than the one you're using. And so their memory may be exhausted a lot quicker than yours. You can't just say, tough luck, suck it up, buddy. You got to deal with it. You got to deal with these things. So assertions are not to deal with those sort of things. Assertions to deal with logical mistakes. Things that should never happen. You should not be doing an assertion on, I have more memory. Malloc returns something that's non-null. No, that doesn't cut it. You should handle things that are unpleasant, that are inconvenient, like out of memory, out of disk, so out of resource, a disconnected database, a congested network, and a network timeout. those are things you should handle with exceptions. Assertions are the things that are logical mistakes. They're assumptions that you're counting on. And you want to fail early, okay? So you want to document. And what's the benefit of this? It documents the assumptions, it reduces the likelihood that an error will slip through, it reduces debugging time, and it can improve thoroughness of tests. These are A1 good things, and these are trivial to do, and often they serve one of the most valuable things by documenting assumptions, one of the most valuable uses, okay? Let me just describe, in other contexts, when I cover this more later in the term, I'll show some more examples. But ladies and gentlemen, let me tell you in C, in Java, as well as in many modern languages, it's trivial. Even in languages like C, it's straightforward. You include assert.h. So how do you do an assertion? There's actually an assert statement in Java, what is it, 5 and above or something? So you say, for example, assert, you know, this certain reference to, you know, heap dot size not equal to 0 or something like that. And then after a colon means something special in an assert statement. You could say something like, empty heap discovered or something like that. And what's beautiful is if this happens, if it turns out that the heap size is in fact 0, then this thing will be issued as a message, an exception will be thrown using this message, and it will propagate up. And someone can handle it further up and know how to handle it, but if no one handles it, it will pop out, for example, in the console. But you can handle it and have it, for example, send you a message via email, or you could have it post to an HTTP server to record cases where your program has crashed on someone's desktop or on someone's device. It'll post automatically logs which report where these things are. So the beautiful thing is when this exception is thrown, it will record actually where this is, what line number, what module it's occurring. So go and read about assert statements. I don't have time to go into them now because it will just shortchange other important topics. They're trivial to find out about. They exist in most modern languages. You can use them in C and C++ as well. And they're really good and helpful. So I would urge you to go find out further about them. Any questions about assertions? So they're literally as trivial as oh, I want to mention one thing. Oh man, I should have emphasized it. Let's suppose I had an assertion in here that I want to. So maybe I have an assert. This is kind of a lower level assert, but suppose I wanted to have one that is array identical or something like that. Array identical, and I want to compare some sorted array sorted with the result of some other algorithm. So, bubble sorted or something like that. The bubble sort on the same input that so maybe this occurs at the bottom of my sorting routine, my quick sort, and I have some array sorted that came out of that, and I want to compare the contents of that with the results of calling bubble sort on some input that I used to sort. So here's an assert that's testing something that could be quite expensive. If I have a million items in this bubble sort could take quite some time. But during testing, I want to do that. The beautiful thing about assertions, folks, is that you can disable them just like that. So specifically from the Java virtual machine parameters, you can do -disable assertions. And what this will mean is that textually, this assert will remain in your code, but it'll be ignored by the compiler. It'll be ignored, in fact, by the letter. So this assert won't run when you do disable assertions, okay? So in other words, while you're testing, you may want to do this big check, which takes sometimes lots and lots of cycles, lots and lots of time to do. But when it comes time to giving this code out to the user, maybe you want to disable assertions. And you can do that either overall on the program or for particular modules. So some modules you might want to leave the assertions enabled and some disabled. So it's beautiful. You can have these things that check sanity. They can be used extensively during testing. And you can just flip a switch and have them disabled for the sake of giving out your code if you want to do so. And sometimes the assertions do impose performance overhead, so it may be valuable to do that. Any question about that?
You ever have assertion user code or sometimes?
Sometimes you'll find a debate in the community about this issue, and I don't want to push one particular line in it. There's arguments both ways. But what's uncontroversial, what will be uncontroversial is that certain particular assertions, which may be heavier weight in terms of their performance implication, you might want to disable those. Okay. So I'll give an example from this class of where a team could have used this and would have saved them major embarrassment if they had done so. So some years back, maybe 8 years back now, 7 years back, we had a team in 371, met in this very classroom, I think, and they designed, how many people here have used Click and Go on the Saskatoon website for buses? Yeah, okay, familiar with that. So this is before Click and Go. So they built basically a Click and Go thing before the city. And who knows, maybe it inspired something on the part of the city. But what happened is that they had a really clever algorithm for routing people between, where they were coming from and where they were going to. And they kind of reasoned through this algorithm and thought this should work great, really efficient, and it was a potential bottleneck. In other words, if it hadn't been efficient, the system might have taken too long, would have timed out sometimes. So if I said, I want to go from Greystone Heights to the airport, maybe it would have taken a minute to do the search, and now with their efficient algorithms, it only takes 20 seconds. And so, it's much better for the user for that. And they reasoned about this algorithm and thought, yeah, this looks pretty good. And so they turned that in. Now it turns out that there was a trivial algorithm. In fact, I think they originally had it in their code to do it via a brute force way, to just search all possible combinations, right? And that was totally trivial to write. It was like 3 nested loops or whatever. Totally straightforward to write. But they stripped it out in favor of their efficient algorithm. If they had just done this, if they had, for the sake of testing, had both algorithms run and compared the results, they could have found much sooner, long before the last day that they turned theirs in, that their algorithm had problems, and they could have gone in and found those problems. But instead, their code, they simply stripped the inefficient algorithm out, used only the efficient algorithm, and therefore they missed that opportunity to catch that error. They could have had that check in there, identified the problem, fixed the problem, and had a spiffy, efficient algorithm that was actually correct, instead of an efficient algorithm that was wrong. Okay? Efficient but wrong. So just remember, assertions are your friends. This comes at no cost to the user because you can disable it so lightweight without changing the code base at all. And you'll have to decide for your project whether you want to strip all assertions out or just strip them out from certain pieces of the code, which again is supported with the Java flexibility for assertions. You can take them out of particular modules. Okay? Okay. Assertions are your friend. Ladies and gentlemen, I would like to see, I want to see, I expect to see, I will be disappointed if I don't see your code littered with assertions. Just get into the habit when you're writing code and you're thinking, am I sure that this is not null? Or am I sure this variable has been initialized? Or, am I sure that I went through that loop at least once? Am I sure I only have to deal with that I'm sure this is a positive number? just put in an assertion. Whenever you think about an assumption, just stick in an assertion reflexively. That's what I do. Just stick in assertions. It lets other people know what your assumptions were when looking at that code. And it will check it. And if you made a mistake in your assumptions, it will alert you. And you'll be able to improve that code much quicker. It will help you debug it. So I want to see in your code lots and lots of assertions. Okay? Easy, lightweight, trivial to put into place, great for documentation, and a best practice out there in the industry. Please put them in. Okay? Okay, so those are some preliminary comments on assertions, and we'll be coming back to this topic